Mr. Crispin Enterprises, you're through to the talking department. Yes. Yes. Very well. Mr. Crispin here once again, and welcome to my workshop. Now, you could be forgiven for thinking this has become somewhat of a talking channel of late. Well, don't worry, it hasn't. It just so happens that all my talking videos have come out one after another. Now, today I'm off to York. I'm going back to an old club of mine, and I'm going to be delivering a little presentation for them on what I've been up to over the last 2 years. And seeing as I'm going, I decided to take the camera with me. Now, this video is for the hardened audience member only. Not only is it quite long, but I'm also going to be covering topics that I've already covered in the past, albeit this time with the additional benefit of some live audience interaction. So if you are interested, then watch the video. I'm going to drive to York now, and where's my laser pointer? Okay, well, thank you all for coming. I'm Crispin Cousins. I've been a member here for 11 years now, and Richard's invited me back to do another talk for you. So nice to see you all here. Thanks for coming. I'm in competition this evening with Strictly, COVID and the petrol shortage, but hopefully you all found somewhere to park your bicycle. Now I'm here, Richard's named a talk for me, More Tales from a Workshop, and I'm basically just going to talk about the things that I've done over the last couple of years since I was last here. Some of you may be aware that I make engineering films for YouTube, and so when Richard asked me to do the talk, I had a bit of a think about what to present, because I didn't want to just re-present everything I've already put onto YouTube. So I'm hoping that the live audience will give us the opportunity to discuss a few things as we go along and have a few insights. So this evening I'll be talking about the following things. I've got a bit on the manufacture of piston rings, and just out of interest, how many people here have made piston rings or are knowledgeable on them? Okay. We'll have a bit of a discussion. Hopefully you can give some input, those of you who've done it before. Now, trials and tribulations, that follows on from the piston ring, so you'll see how that ended up. And I'm going to give you a bit of an insight in some of the YouTube stuff. I've been working on the overhaul of a Harrison lathe, and the question at the end will come to, why are you building that? Reference to model engineering projects, and it's a question some of you may be familiar with, so hopefully we can have a bit of a discussion when we get to that. Piston rings to start, and for the locomotive I'm building, I knew I would need some piston rings, and in the beginning, the first time I really came across any technical information regarding piston rings was in this book that I picked up, or I was given a long time ago, the Piston aero engine book written by Bill Gunston, and the piston rings detailed in that are highly complex. All kinds of different profiles, tapered sides, and so knowing I had to make some piston rings, I was thinking these sound rather difficult. I was relieved to find out, however, in the more model engineering and steam world, they tend to be much simpler profiles, so I thought, oh right, that's easy. I had been assuming the profile would be the difficult bit. And so just as a quick recap for anyone who's not familiar with these topics, the very most basic thing used in model engineering is your traditional soft packing. So you can see the groove here in the piston, and the soft packing, typically a graphited material or something similar, is formed into that or wrapped around, and rather than acting as a piston ring, that's just more of an improved seal. So obviously not as good as a piston ring, but better than nothing at all. The simple split piston ring seems to be the common choice, so that's just a cast iron, in this case ring, with a split in it, in cross section just a plain rectangle, and then there's other variants on that involving different shaped splits, so some have an overlapping edge, some don't, and then you've of course got your Klupert ring, which in case anyone's not familiar, this is a ring that's split all the way around the circumference in a kind of spring effect almost, or a bit like a slinky. And although you've got two gaps, as the bore sees it, there's no gap. So there is a video on YouTube of someone making these, but I decided for the locomotive I'm building, which is a springbok, that I'd just go for straightforward piston rings. And doing a bit of research, I found there's a quite well documented, very basic method that a few people here I know have used, and when you look it up on the internet, this is how it appears. You start with a tube, you part the rings off to form a basic ring, you then break the ring, either break or cut. The preference seems to be to break it, so either by forcing it over a taper, or I've seen some people just literally put it in a vise and hit it sideways, or some people will expand it outwards on the back of a 3-jaw chuck. So just sort of, and normally it just breaks in one spot. So that was the basic method, up to the splitting, and from there the use of some kind of wedge or packing piece, because what the process is to over expand it, anneal it so it holds that form, and then when it returns to the bore diameter it's under some tension. So that's the basic method. Form a tube, part them off, split them, or use a very fine slitting saw or hacksaw blade if necessary, put a wedge or gap in, anneal them, and then when it gets down to the bore size, because it's been annealed at a larger size, it's trying to expand open. So that's the basic method as I found it. I took it away and thought about it a bit, and what I'm going to do is show you the process I came up with, and then at the end we'll have a little discussion about what the differences could be, and any thoughts will be interesting. So I started off fairly in line with that method. I just turned the right diameter down, or a slightly oversized diameter at this stage. That's fine grain cast iron, by the way. Anyone who's asked Richard about this will know he sort of suggests fine grain cast iron or meionite rather than sash window weights or a lower grade cast iron. And from there I then started to proceed differently to the method I'd shown. So the problem obviously with boring a tube out and then parting them off is that first of all you waste all the middle down the you waste all the material down the inside, but also as you part them off you're leaving yourself a parted edge on the back, so you can't finish them particularly nicely in the first op. So whether you do a secondary op or whether you just accept the parted off surface. So what I came up with was this method here. This is the cross section I'm trying to produce. So this is the outside diameter, these are the side walls, here's the internal diameter and internal chamfers, just to aid it in getting the piston on, getting the ring onto the piston. And so what I did was I came in with a grooving tool onto that diameter, and I worked my way along, roughing out the gaps and then finishing the side walls with a grooving tool, so that all the rings on this side and this side are fully formed in the first op. So I finished the OD and finished all the sides in this op. And then to put those internal chamfers on, I ground a high-speed steel tool that looks like this, and then just went down the groove and did a side-to-side move to put on what would be the internal chamfer. So going back to this, I've basically produced something of this cross-section in 8 locations down the length, and from then I was able to free them from the stock material by trepanning. So I ground a trepanning tool with a slight offset angle here compared to the tool body, so that this was all in clearance as it went down the diameter, and that allowed me to feed along, and the rings came off. So you just feed through with the trepanning tool and the ring falls off, just stop the machine, remove the ring, and then go on to the next one. And so basically the rings came off fully formed in one sequence, and I had this diameter left for future use. So that was fine. That was just that's just how I machined them. But the thing, as I'm going to explain with the piston rings, is machining a ring isn't really the difficult bit. So I decided to go for the splitting method rather than cutting them. The only point of interest I can really find on the difference is obviously a split gives you, in theory, the potential for a narrower gap, because your average cutting device is probably going to be at least 10 if not 15 thou. Some people I noted ground hacksaw blades down to the minimum they thought could get away with, and then cut them with a hacksaw blade that's been thin. I think the one downside of splitting them is that the fracture is not particularly neat, and if you look at it under with a loop or optic visor, you can see that the fracture isn't always particularly clean, and you can, on 2 of the rings out of the 8, there was a further hairline crack developing. So it might look like it's split, but when you look at it, it sort of split at a funny angle and then come back, and where it was going there's another crack. So potentially, I don't know, would that bit drop off one day?
How did you split them then?
Well, I'll show you. So I split them by starting with the ring, and then I just held them on a block of wood, so the wood's clamped in the vise, and with a triangular needle file I put a notch on to encourage the crack to start somewhere, and they all did crack on the notch. There is an argument for just letting them split naturally, because in theory it splits on its weakest point. But I put a notch on to try and have some control over it, and I then made some little tools. I made an internal collar with a shoulder on it, on the outside diameter, that is split. So the notch on the piston ring is then aligned with the split in the collar, and the internal bore of this collar has about a 4-degree taper, and into that 4-degree taper goes a matching plug. So it's 2 tapers together, and obviously as the male taper is driven in, this opens out and the diameter of the OD expands, and then under a press, which is, well, you can see the end of here, that naturally causes the ring to split. So that gave a method of splitting that was quite controlled and quite uniform, so it was encouraging the whole diameter to go out evenly, as opposed to the 3-jaw chuck method where it's sort of being turned into a triangle. I think driving the ring down a Morse taper seems effective. If, depending on the size of the piston ring, you may need to find a number 5 Morse taper or something. The problem is how you would keep that ring square and actually push it with any kind of, probably make some kind of tube. And I don't know if you can see from the distance you're at, but you can see the fracture. Although it's a clean break, it's not particularly neat. And on, as I said, 2 of these rings, you could see where the fracture had almost started to return. Wow. And so I made extras for future eventuality, so I didn't end up having to use those 2, but it's worth noting that obviously cutting the slitting saw, you wouldn't be subject to such things. Now I then stretched it onto a mandrel, and I know at first I just put a wedge in there, and I noticed that the ring's circularity was totally lost. As soon as you put a wedge in there and just expanded it here, it basically pivoted out like a pair of calipers and was no longer circular. So I thought, what I'll do is make a circular mandrel and encourage the ring onto a circular mandrel, and that kept it circular. So I stretched it out onto the circular mandrel, stacked all of them up, and so you can see the gaps there, and then I bolted a cap on, and that was the arrangement for annealing them. I heat treated them just with a propane glow lamp to a dull red, and then just let them cool slowly, and that was as technical as the annealing got, and that gave me a finished ring. So you can see there that was the cross section. I was working to 1/8 of an inch by 1/8 of an inch to the cast iron, and after the annealing you can see that gap has shrunk down a bit. So there it's about 3/16 of an inch, and it's come back down to about 1/8 of an inch. So, any thoughts? I'll let you open, Richard.
Well, the ring isn't circular. I mean, I drove them up a Morse taper.
Yeah.
With a collar, and I got a rough split.
Yeah.
Which I thought would come back together perfectly in the bore. This is on the Wren, and the Wren has had those piston rings in for 40 years, and they're still not bedded. They're still not fully bedded after 40 years. They're still out of circle. So what you're saying is right. They are not a circle. But bloody hell, it doesn't really matter. I mean, the thing has run spectacularly
Yeah.
for 40 years, and so it's good enough for me.
Yeah.
But I know you're a perfectionist, and I know you want it right.
Any other thoughts? So those of you who've made piston rings before, how did the method compare to
It
what you...
matters for internal combustion.
Oh, yeah.
whether around or not.
Yeah.
Of course it does.
I think obviously these steam locomotives would run whether or not the piston ring is round or not. I think the question I'm getting at here more is how do you produce a round piston ring?
I've tried all the ways and I haven't produced successfully a consistent batch.
Yeah,
of round ones.
and what methods have you tried?
Yeah, I've tried just making them to size and breaking them and annealing them with a gap, as you say,
Yeah,
and then making them oversized sort of with the gap,
Yes.
the spread built in,
yeah,
breaking the gap out and then filing them to fit in a ring which was the same size as the cylinder,
oh right,
and then leaving a little bit on the outside to put it on the mantle and skin it. And it seems like I go to about an inch maximum, and it seems to be stored that continuously cast iron. It seems to have a soft side and a hard side,
oh right.
That's
and
interesting.
no matter what I do, I seem to get them out of round.
So that's even with the method whereby you're finished machining
Anyway.
them anyway. Yeah,
Wow.
The last little skim, it doesn't seem to. It seems to go again.
right. Mm.
That's interesting.
Yeah, I mean you do notice when you turn that stuff that it's light and dark.
Yeah,
When
different
it's spinning,
sound.
you can
Yeah.
see light and dark as if it's two different grain
I
sort
was
of
surprised how
directions.
chunky steam ones are. I've never seen a steam piston ring.
Yeah, well we'll come on to that.
Crude.
Yeah, Mike.
Well, I was just going to echo that. But in a petrol engine, the ring probably wouldn't be square, it would be
Yeah,
more rectangular,
yeah,
much thinner.
yeah.
And when you try to split it, it's
Oh, it
a
will
lot
flop
more of a
around.
weird creature to slide down the mandrel.
Yes, yeah. So if the ring's thinner, then splitting it becomes more difficult because of the radial. Yeah,
Well, Richard's horrified by the way I do it. I put it between two pair of smooth faced pliers and I just crack them.
yeah,
Yeah, but if you think about it, you've got 3 inches on an inch ring. You've got 3 inches of unstressed cast iron. So
Yes.
where is it going to break? What between but yours?
yeah,
And all the rest is unstressed.
yeah,
Your ones, they've all been stressed to their elastic limits all the way around.
yeah.
Yes.
Mm.
It's not wrong. I'm not wincing. I've never heard that way done.
Well, to me, it's just the obvious way.
Can we just pick up on this is centrifugally cast iron, isn't it?
It's
No,
supposed
it's just it isn't centrifugally, not the
Ah,
stuff that we
Well,
do.
hang on. Continuously cast.
It just comes out like toothpaste, doesn't it? Out of the mould.
I'm no expert on the casting of. I
Well,
guess it's
From what I've seen
depending
on
on where you
TV, it
get
just
it.
comes out like toothpaste.
Yeah,
I thought I was buying centrifugally cast 2-inch.
I would buy it if I could.
Ah,
yeah. Well,
What's
What grade are you using? The grade 17?
I've no best meionite centrifugally cast. I thought I was using,
I've never
but
done
that
it.
was 40 years ago. So I'm well out of date. I'm sorry.
We'll have to ask the suppliers how they actually
What
make
did
it.
you use?
I just used the cast iron that Poly Model Engineering
Yes.
supply.
Yeah,
So
well,
it's definitely cast.
the thing is that when I inquired some years ago about meionite, somebody said to me, that's not a grade of steel, it's a trade name.
Yes, well, yeah. I mean, meionite
It's
is
not a grade of steel.
No.
If you ask for,
Iron.
iron, I beg your pardon. So, you've got to specify what grade of iron that you
Yeah.
need to use.
Mm.
But from experience of my other colleagues in other societies, they've always used grade 17.
Yeah, but I would guess you could get grade 17 centrifugally cast and not centrifugally cast.
Well, it just depends on the
Oh, so I've never
size
looked
of
into
the
it,
bar.
Yeah.
Does it?
I suspect the bigger sizes you might
Mm.
get a
Centrifugally
cast,
cast.
but in small sizes.
I'm sorry, I don't know.
Yeah, you-
Anybody else know?
So which of the other piston ring builders then have used any other methods to what we've discussed? Yes?
You get to the stage where you have the size piston ring on your billet.
Yeah,
But what you do, well, what we did was we made the width of the piston ring larger than the finished size.
mm-hmm.
So you'd cut it, anneal it, and then it would spring out. The OD of the actual finished piston ring would be larger than what you required. And then this would then be put into a recess, closed in, under, you put, say, a tooth-house shim or something in between the gap. Close it in so you could actually hold it in with a pad on the outside.
Yes.
And you could machine the OD of the piston ring exactly to the bore size you wanted. When you release it, it will always close down to that spot on OD size. And then all you do then is you make another fixture to hold the piston ring in and machine the edge. The way you would hold it would be to make a tapered insert to go in the internal bore of the piston ring, so that you could squeeze it out to its true diametrical dimension inside the recess. And then when it's released, you have a piston ring that has an absolute true OD.
Right. Okay.
I wish I'd done that.
Any more thoughts before we move on?
It's just a slight aside, and the gentleman to my right here, Richard, knows the problems I've had with a particular locomotive. And in the end, one of my sadly passed away colleagues now took it away and sorted it. And I have bronze rings in bronze cylinders. No, and everybody goes, but they worked and they're absolutely perfect. So it's not all about doing iron rings for iron cylinders. Most gunmetal cylinders or whatever have O-rings in. And that's what, or packings. My little engine actually has bronze rings and bronze cylinders.
Right.
And
Okay.
it works
Interesting.
and it doesn't seize up.
Good lubrication. Right. Okay. Well, thank you for your thoughts. We'll see what happens. So the outcome. It was impossible to get the ring onto the piston. So, as you mentioned, they looked a bit chunky. That's what I started thinking.
Quite a stiff ring you've got.
The rings were far too powerful. So the amount of force it took to close them was far too much. So the force they were then exerting on the bore was too much. The friction was just, you were struggling to actually move them in and out. And the gap wasn't big enough. This is something I still haven't worked out. So I split the ring and then annealed it, and even closing them back together with the ends hard up against each other, the diameter was bigger than what I'd machined it to. And I, looking at it closely, it looked like whatever happens during the heat treat to the rough ends of the split, they slightly change shape and they don't nest back in with each other.
How interesting.
It would not close back down to its original size, so I had to just needle file very carefully enough of a gap to get them to go back in. But even though I could then get them in, they were far too powerful. There was problems, so I had to stop the job. And so you can see in relation to the bore how chunky the ring is. So it's a very tight fit, and they are out of round. Can you see here to the daylight?
Yes.
I could get a tooth-thou feeler gauge through that. So having needle filed them to get them in, not only were they too powerful, but daylight was coming through, so they were too powerful. They wouldn't fit in the bore, but I did get the overall width right. So I had to do some research, and the two names that appear in the topic of piston ring research and model engineers is Professor Chaddock, who was a writer for Model Engineer, and George Trimble, who worked for NASA, and he produced a 16-page document. He was an internal combustion engine builder. And Mike Sayers, the Bentley engine man, he sent me an article by Trimble that he had done over the course of building his Trimble had spent a lot of effort trying to get his piston rings right for his internal combustion engines, and produced a 16-page document on his method showing the fixturing, all the science behind the curves and how it all works. So to just recap then, so okay, I did the rings differently to making a tube, but that doesn't really matter, that's just how you form the ring. So the ring, there's no problem with the ring other than its dimensions, but when it came to splitting them and the further processes, this is where I think the problems crept in. Trimble doesn't recommend breaking them because he's got a detailed article from a sort of material scientist point of view, but he thought breaking them induced stresses that they would never recover from fully, whereas if you just cut them, then you'd not put the rings through that stressing. The main difference here, as I'm going to show you, is in the wedge. So I stretched them onto a circular mandrel to try and keep them round, but all the science actually says you have to use a wedge and let them go out of round, so that when they stretch back in, the forces are equal. And when it's sort of written out, it is quite obvious. If you bend it out, so it does a hinge sort of manoeuvre, and then you set it there, it's out of round. When you reverse the motion, it pivots back in around the same point and reforms a circle. When you make it stay round, then when you come to put it back in the ball, it pivots back in. So I actually just caused the opposite of what I thought I was fixing. So that was the cause for the kind of roundness error. When you mentioned that you hadn't managed to get a round one, what kind of size errors are you talking about? Is it just a visual inspection, or?
Yeah, when you put it into the, you see the light through it.
So you're not got a number on 1 thou, half a thou?
Less than 1 thou, I would say, yeah.
Okay. So I think that the error for why it was so far out was entirely down to this. I thought I was improving the process, keeping it round, but because you've then set it round, when it bends back in, you've lost the roundness. So a wedge or packer is sort of the way to go. Trimble uses a dowel so that he can actually calculate how far the contact points are. He has a dowel on a fixture that fits in, because obviously once you've cut a straight slit and you open it, you've then got a taper. Yes. So he uses a dowel to maintain the proper tangent points. But that was the main thing. There were 2 other things. I've already mentioned the gap, so I couldn't get these to go in the bore because of that gap. So clearly that was an error in the method, but also the cross-section dimensions. And I've done a lot of thinking about this because the drawings clearly show a 1/8 by 1/8 slot in the piston. So when you look at the piston, the piston ring groove is 1/8 of an inch wide and 1/8 of an inch deep, and there's no detailing of any piston rings in the drawing. And what I actually think is, of course, it's not been designed for piston rings.
It's been designed for soft packing.
It's been designed for soft packing.
It's Martin Evans.
Yeah. So so I've made it, not being able to find, because all we've got, it's not hugely well documented, the designs, and so I've had to, quite often with the drawings for this locomotive, you've got to find the missing pieces, and I thought I was finding a missing piece. I actually think it just wasn't designed for that, but I had double checked before I made these, and gone on the internet and done a search, and lo and behold, Model Engineer website, someone's talking about making 1/8 by 1/8 piston rings for their Sweet Pea, which is a similar size locomotive, so I thought, there we are. After I couldn't get these back on, I went to double check this article, and the actual article was him asking why he couldn't get the piston rings on his So more careful reading required next time.
There's of course a way around fitting very tight piston rings, and that's using split pistons.
Yes, yeah, that did actually come up in the YouTube comments. I did video of it. And yeah, a few people just said, why not make a piston as a series of discs that bolts up. So the question came, what are we going to do about it? So I wanted to stick with piston rings and not go for soft packing. And Mike Sayers had sent me this. Oh, sorry.
Well, there is a middle way between this soft packing and your cast iron ring. The piston valve, the pocket valve mazy, has cast iron cylinders, cast iron pistons, with a bronze ring.
Ah, right.
Because this might get down Richard's problem with not bedding in. Because the amount of use we're going to give, well, Richard might give an engine enough use to get a ring bedded in, but most people don't. Perhaps a bronze ring is worth considering for our use.
I have looked at it in the course of the piston valve rather than the actual power piston, but the topic of PTFE rings does come up. So the one thing I can't get my head around on a PTFE ring is the amount it expands during rolling. I think it's very hard to predict. I mean, you could argue that it doesn't matter if it's overexpanded, it's only PTFE and it'll just take the shape, but it doesn't.
The Corpay locomotive has PTFE rings with a step joint.
Oh, right, yeah.
And an enormous allowance for expansion.
Yeah.
And that's in bronze cylinders, so I don't know how that's going to perform because I've not run it yet.
Yeah.
But we shall see.
The thing is that when Richard and I steamed my engine up in the museum many years ago, Richard, do you remember? And it ran fine on air. Backwards and forwards, lovely. Put a fire in it, and it was like trying to drag a cat across the blackboard. It would not move, it would not rotate, anything. As soon as it cooled down, it was fine.
Oh, right.
And that PTFE rings in bronze cylinders, and that's why my colleague took the engine away and did the business.
Right.
Split pistons and bronze rings.
Okay.
But the basic thing was that I'm a lot more worldly wise now. PTFE is fine, providing you check how much it expands. Of course. You've got to stick it in heated steam or hot water and measure how much this expands.
Yeah, I mean, it's very tricky to actually replicate how you. Yeah. Yeah. So
we shall see.
Anyway, the quest was to make a piston ring, and I read this document by George Trimble that Mike Sayers sent me, and he's on the no doubt that he's found the way to make them, and it is a very well written document. And I basically used that and some comments that I got on YouTube for how to fix it. Trimble's method is entirely a one-stage process. So you turn the ring, you expand it, and that's it. What I decided to do was go more down the Professor Chaddock route, where he actually remachines the OD, a bit like you were discussing earlier, and I'll show you what happens. So, in case it's not clear, this isn't an optical illusion. This blue ring is out of round, and the smaller orange lines are round, and this is how I sort of thought how to fix it. So according to Trimble, you calculate the correct piston ring width, so the radial section, by taking the bore diameter and dividing it by about 27. He said somewhere between 25 and 30, so I just divided it by 27.5, and that gave me a ring radial thickness of a 1/16, pretty much dead on, as opposed to an 1/8.
Yep.
And because the gap was also too tight, I had all the sort of components there to fix all the problems. So what I did was I allowed the gap to open up, to take the bore bigger, and then that gave me metal on both the outside and inside to remachine them.
Wow.
So, and that's what this illustrates. So here's the original 1/8 radial thickness, and you can actually fit, by opening the gap up, which I've not drawn on, if you open the gap up, you've then got material both sides to machine what you need. So I rebored the middle, so I just got a piece of aluminium and made this rework fixture. So the bore of this aluminium is 4 thou bigger than the cylinder bore, which took the ring out to about the right gap, and then this step here is pretty much the same height as the ring, so those 4 flange screws just pinch it in place So it's naturally expanded out into the diameter, and then it's pinched backwards by the screws. And then I came in with a boring bar and thinned it down until this was, you know, 4th thou over a 16th wide. So that took the, sorry Richard?
Okay, I'm sorry, I'm just understanding it.
So this, what I'm doing here, I'm taking the bore to the new determined ID, and the OD is slightly oversized because it's in a bigger diameter than the cylinder bore. And once I corrected the ID, I then made a sleeve of 4th thou bigger than the locomotive bore, and then 3 at a time I put them into the sleeve, clamped that sleeve back in on this mandrel with a cap, got it running true, and then I pulled the sleeve off. So I've now clamped the rings at a position where there's 4th thou left on the diameter.
Yeah.
Yeah. And then I just very carefully machine them down. So you can see here, I blacked them up before I started, and you can see the out of roundness on my first top. And then I took the 4th thou off, so 2 thou radially, which was hopefully just enough to clean it up, and that's the cleaned up rings then.
Well done.
So I hopefully, is that process clear?
Yes.
So yeah.
Yes. Brilliant.
And that, to my inspection, completed the task. So the gap ended up about 10th thou, which is a lot bigger than what people on the forums were saying where they wanted no gap. But if you look at anything more, you know, our internal combustion, I know the temperatures are slightly more, but by and large everyone's recommending a gap rather than aiming for no gap. Whoops. So I ended up with a gap, and although the angle was slightly different, I couldn't see any daylight.
Well done.
So for that one, for those few piston rings at least, it did work, but that's a horribly involved method. I think if I was going to try and do it again, either I would stick to Trimble's method exactly and use all his calculations and fixture drawings and try and mimic that method exactly, or I would just make them oversized to begin with, and except I was going to have to machine them down after annealing. There is an argument that if you're going to machine them down after annealing, why bother annealing them in the first place? Just make them too big, mill a slot that's too wide down it, and then and then just squeeze them in a tube then and remachine them and cut out the annealing altogether.
What, can I just add that when we see a gap like that, as engineers we think, bloody hell, that's an enormous gap, but it's not, because the piston is either side of it.
In this bore, the piston is 1.5 thou smaller.
That's right.
Than the bore diameter, so that
Also, when that ring heats up, it's just going to.
Yeah, the gap will close.
It's going to come together anyway.
Yeah, once you've got the piston in there, only 3/4 thou of that will actually be visible. So
well done.
I've given my answer, but if anyone's got some thoughts on how a piston ring should be made, feel free to share them. But I think they continue to be tricky, is all I can say. But Mike Sayers says he follows this thing for his Bentleys exactly, and he's perfectly satisfied with the results, and he's got high standards. So has anyone here come across the George Trimble method?
No.
No. Unfortunately, it's copyrighted in America, the full 16-page thing, but there's a 3-page condensement of it that he did for Model Engineer that is available, and I could probably find those article numbers if anyone.
Yes, please.
I can get them and have them for the
Thank you.
newsletter.
Very interesting.
Yeah, but that's my tale with piston rings. So
Did you manage to make the new piston rings out of the unworked rings that you've parted off the first
yes,
bar?
yeah. So of course the alternative was to just start again.
Yes.
But I'd already made all the tooling, and I'd have had to make a whole other set of tooling. I had enough rings to play with, so I just machined them down. It was a bit of an experiment.
Did any of your readers rumble you?
Well, after I did the first video, it just showed me them making them. I was still oblivious to all the problems, and quite a few readers did sort of spot what was coming. Probably only about 5 people, but
Okay.
there were people that spotted it, and Mike Sayers sent me a nice email saying, just a thought, but
Yeah.
read this.
I wondered how you were going to get along.
Well, I mean, the interesting thing is I've not done much with piston rings, and so because I thought I was working to dimensions that were all, set in stone, I was making them thinking, isn't this interesting? How on earth is this going to go on there? But I thought, well, it must work because it's drawn out, but obviously it didn't work. So if I'd thought, hang on a minute, this isn't actually going to work, I might have come across it sooner.
So what sort of profile was Mike Sayers using for rings?
Pretty much what you've discussed, so a much flatter, but just plain ring.
Thinner ring.
Just still a plain snap ring, but sort of, I think he said about 1.5mm wide as opposed to an 1/8 wide, and I think square section as well, so really very small.
That's what I use, a 20th of the bore,
Yeah,
which works out at 50
he
pounds.
might have even said smaller. But yeah, compared to those,
Well, the 40 pound now, because I've sharpened the tool once or twice.
I mean, it looked like you could just snap them with your fingers, the ones he was making. So
There was one other thing, when you've annealed them, I think it's accepted that they do grow about 1/1000 inch.
right, okay, that's probably why they didn't fit back in then. So you're saying as you anneal them,
Yeah.
the length is growing as well.
Yeah.
Right. So the releasing tension during annealing has caused an exaggerated length.
Could be any shape, really, couldn't it? You think
Yeah.
about any shape.
Well, I mean, the idea of clamping them was to hold them,
Yes.
so they couldn't move. But yeah,
Could I ask you, the original ones that are 1/8 of an inch thick, if you'd have made 2 that were 1/16 of an inch thick, and put them with a gap at the opposite sides, would that work?
yeah. So you
Easy to
mean
get on for us,
yeah. So you mean split them and turn them around.
Yeah.
Someone did mention that. The interesting thing with a piston ring is whatever thickness you made the ring axially, the radial forces are still the same.
Yes.
Yeah,
So
yeah,
it
yeah.
would still have been too strong, even though it's thinner. So obviously there'd be less for the given ring. There would have been less friction on the ball because it's only 16. Then you put 2 of them in. So,
Oh yeah,
but yeah, it would
yeah.
have
For the ceiling around it.
for the ceiling. Yeah, although obviously you've got 2 of them, so in theory they're like that. But here's a question: does anyone know whether piston rings rotate inside the ball as it's running?
It depends on the
Yes.
engines they do, yeah.
Petrol engines, they do, yeah.
Do
So
Yes.
I have
Yes.
pairs on them.
yeah. So obviously in a petrol engine, sometimes they're pinned, aren't they? So that they're in a 2-stroke, so they can't.
That's why you set them at
120.
120 degrees, so
Yeah.
that they all rotate at the same speed.
Yeah.
Suits have got
Well,
parts into it.
That's the theory behind it.
Right.
But
Yeah.
they do rotate, like valves rotate.
Yeah. Yeah. Well, I mean, it could quite be that one day they rotate and line up, and they're both a gap.
It's not likely.
No.
No.
Just from a man who's never made a piston ring
Yeah.
at all, I know I've seen films and just listening to what you're saying, please forgive me, but when you make your bore's near perfect, yeah?
Mhm.
Make your ring is near perfect. The obvious, so what the problem you have is to put the tension on, isn't it? Is how do you put the sprung tension on?
That's right.
One without overspringing it,
Yeah.
and 2 without. So the annealing process to me sounds awful. So, but the physical stretching is the same thing. You're absolutely impossible with it, almost,
Yeah.
aren't you?
Almost. I think that's why the only way I could get it anything like was to remachine it in its finished condition. I mean, clearly the piston ring manufacturers know how to do it. I don't know how they do it,
I
but
think they shop in the inside, don't they?
no idea.
I don't know.
Um,
I'm just so amazed that I've got away with it for
Little
40 years.
Sorry.
On some rings you can see little straight notches where
Yes.
Yeah.
they've sort of
However
like
they do it,
like a peening
I
effect.
highly doubt that
I don't know
they're
how they
putting
do
them back in a fixture and remachining the OD at the end. So someone knows how to do it. But, and I think the Trimble method does have enough science behind it to get you there. So I'll see if I can
Probably
share
somebody
that.
rolls it round
Can we
So,
consider a
makes a
cup
real
of tea?
long
Yes,
coil of them and
yeah,
it goes
I'll finish
with the
this section.
Well done.
And when I'd done all this, I went to a motorbike expert near where I live, who is very knowledgeable on all these things. And I thought, he'll know how they do this. And so I went with all the dimensions and said, how do you do this? And he said, we just buy them. That was as much as he had to say on the matter. So
they're much lighter in construction.
experience.
Yeah.
The things you're making are great heavy bands, aren't they?
yeah,
But actually, a two-stroke, much far smaller.
far finer.
than
Yeah. Right. Okay. We'll have a break, and
Thank you.
we'll ring the bell when we're starting again.
Very good. Right, let's be having you, please. Back for part 2.
Right. Okay. We'll carry on.
Diverting up a model. Many years ago I got an international tractor. It was very poorly. Using oil as fast as you could pour it in.
Yeah.
I pulled it to bits, went to whatever you call them there down James Street for new reeds. And they were 8 quarters of it. And no, you can't get them, you haven't been making them for years. But I mean now you find the problem, you can get them, but you couldn't then. And I finished up putting 2 sets of rings in.
Right. Okay.
My hell, it's a good compression. And it's never used a sigh of oil in over 40 years.
Right.
Not a bloody drop.
Could be the way to go then. 2 thinner rings back to back.
Yeah. Only I mean, he nearly fell off his perch in bloke in there when I said, give me 2 sets of them. You can't do that, it's a bloody old fuck.
Yeah.
You got them, it's been perfectly alright.
Yeah. And the other point I noticed was, again for Richard, on a full-size locomotive, what sort of section are the piston rings, and what would the typical bore diameter be of, say, a mainline passenger?
22 inches, 24
ball.
inches,
Yeah.
and the rings would be 3/4 of an inch by 3/8
Okay.
section.
So again, quite an elongated profile compared to an internal
flat,
combustion.
Flat,
Yeah.
flat.
In the Trimble article, he did go into a bit of detail on the pros and cons of different ring widths, and pretty much the only consideration is that the longer it is, the more friction you have. There doesn't appear to be any change in actual forces on the bore, or the only difference with having a longer piston ring is slightly more friction.
Interesting.
Okay, so we'll leave it there for piston rings. Back to a bit of engineering and machine tool work. When I was here about 2 years ago, I showed you a Harrison lathe that I'd acquired, which had come from Burton College, and it was in a bit of a state of disrepair. Now, in case you have forgotten, it looked like this. So it's a Harrison 190, fairly similar in stature to a Colchester Triumph 2000, that kind of size machine. Much more common than the Harrison 190 is the Harrison 15-inch. It's a fairly interesting machine in that it sort of represents when machine tool design started modernising. There are aspects of both traditional machine tool design and newer machine tool design. It is an imperially built machine, so all the screw threads are imperial, all the sizes are imperial. They've just converted the capacity to metric, 190 millimeters, and the screw cutting is metric. Although I believe some variants of this and the 15-inch lathe actually had a screw cutting gearbox that could do both metric and imperial. So it had been removed from Burton College and put into storage, and just sort of sat there for a long time. It had a bit of occasional use, but needed quite a lot of work. And I remember, when I first got it, I thought, I'll just clean it up and then it'll be. But it's taken me about a year. I've not worked on it solidly. I've sort of just done bit by bit. So 190 mil capacity, although it does have a gap bed for additional capacity at the chuck end. It's quite a well-spec machine. It's got a hydraulic tracer, I took the tracer off to move it, but on here it fits a hydraulic tracer. Is everyone familiar with a hydraulic tracer? So at the back of the machine behind the bed, you have another bed, and you can put onto that bed a template or a profile, and then on the back of the cross slide is a hydraulic unit with a tracing foot on it and another slide on the back of the lathe. And so as the slide on the back goes along, when the foot goes in and out, the tool goes in and out. So basically it's just a direct one-to-one copy, directly off a template. So perhaps for wheel treads, quite nice. The great beauty of a hydraulic tracer or any tracing thing is that you can generate a form with effectively a single point. So rather than having to have big heavy form tools that come crashing in, you can trace a form and the metal removal can be more refined than having to plunge in with a form tool. And of course longer forms where a form tool isn't practical, it's quite handy. So one thing to mention is this Angus threading attachment. Has anyone here come across an Angus threading attachment?
No.
Well, it fits on just here, and so traditionally screw cutting on a standard lathe using the threading dial method.
Yes.
So your weight, obviously your lead screw's got how many teeth per inch, and depending on the thread you're cutting you have to get the right denominator. So normally, to cut a long story short, when you're screw cutting you have to hang around while the screw cutting dial comes round to the right place and engage it, and sometimes you might be waiting a minute, if it's an awkward number of threads. What the Angus threading attachment does is it has a gearbox inside it, and that's what's behind here, and it basically allows you to run the lathe at 500 RPM, and it won't let you engage it on the wrong one. So you set the gears inside here for the pitch you want to be working on. You've got the lathe running at 500 RPM, so the gears are going around much quicker, and you put the handle down, and as soon as it allows it to go in, it's off, and when it hits a stop, which is along the bottom of the bed, it then knocks itself off. So it knocks the lever out of engagement. So a bit scary, but it allows you to screw cut at 500 RPM and not have to wait while the threading dial comes round. So that's the Angus threading attachment.
How's it spelled? How's Angus spelled?
Like that, Angus. I've never seen them on a small machine. I've seen them on Colchesters and Harrisons of that kind of size, and it is purely a time saver.
Good idea.
So why not to overhaul a lathe? Now I'm going to put Richard on the spot here. When I first started in model engineering, you said the number one thing not to do is buy a lathe and take it to bits.
Yep.
Yeah. Would you want to expand on that?
Well, people, the thing is to use it as it is, but buy a good one and use it, which is what you did with your ML7.
Yeah.
But so many people, and a lot of people in this club, buy a machine, take it to bits, come to an insuperable problem, and never get over it. There are several members in this club who've done that. I'm sorry that that's... taking things to bits is not a good idea. So
yeah, the argument is that if you've got a machine tool and you're trying to build a locomotive, you should get on and build a locomotive.
Dead right.
Because what happens is you think, oh yeah, I'm going to take it apart this week and put it back together next week. And
next week never comes.
What happens is what I'm about to show you.
Oh, go on, show us.
You take it to bits. So I've given it a clean over, which you think, oh yeah, I'll clean it in a few hours, but by the time you start scrubbing, it takes a month.
Yeah.
And then you find to clean this bit, you've got to mess around. So you take it to bits, and then you leave all the bits on the bench for 6 months because you spread it all out, and suddenly it's not a lathe you've got to clean; it's an entire, all the bits, scraping it all off with razor blades, and then trying to degrease it, and there's an awful lot of bits, and then all these things, the number of surfaces just go on and on. and then you find, oh yeah, I better take the grease nipples and bearings out, oh I better, so that goes on and on. And then, once you've got it to this stage, you think, well, I'm never going to have the lathe in this many bits again, so I better paint it while it's... and then you think, oh yeah, I don't need to, be too neat, I'll just paint it and get it back together next week. But it goes on and on. And eventually I got round to painting it, and I'll be honest and say that the moment I got to painting this was a good 8 months after I took it to bits. Because, because I've got this Myford ML7, so I've been able to carry on doing the model engineering and just do this if I didn't feel like doing any machining. So, I mean, compared to actually machining, it's not very technical, just cleaning bits, as long as you can remember how they went back together. But, so I ended up just scrubbing the whole thing down with endless Scotch-Brite, paraffin, thinners, scrapers, razor blades. Got it to this stage, painted all the aluminium bits in etch primer, then gave the whole thing 2 coats of red oxide, then some machine enamel. And if anyone's ever wanting to paint a machine, I can highly recommend Paragon paints on the internet. And I was quite amazed because all the main machine builders are listed on there. If you want Bridgeport Grey, if you want Jones and Shipman Blue, if you want whatever, it's all on there. And they just post it to you. Primers, it's all available. So I painted it all, and the stage it's currently in is like this.
Wow.
So it's ready to go back together now.
Well done.
So my only justification is the condition it was in. If we go all the way back, I didn't want to use it in that condition because I just thought it might do it some harm. So the original intention was just to take the cross slide and the saddle apart to make sure all the ways were clean.
Yes.
But then, to get the saddle off, you end up having to take the apron apart, and then the lead screws come out, and the tailstock comes off. And I have avoided making the job too big, so I've left the headstock entirely assembled. I just changed the oil in that. There's nothing really to write home about in any of the gearboxes. So that's
Well, it looks lovely. Well
going
done.
back together. All the bits on the bench, of course, you've got to paint them, and the swarf tray comes out in the guard, so it ends up being a lot of work.
Lovely.
And I had I said it wasn't very technical. The painting and stripping and cleaning is not difficult. The challenge I had was powering it, because my workshop runs off a 3-phase rotary phase converter rather than an inverter. So rather than have an inverter on every machine, I've just got one rotary phase converter that supplies 3-phase power to the whole workshop. That's fine, but as I mentioned earlier, this lathe is sort of on the verge of newer lathe designs. Traditionally, you have your motor running and you stop and start the spindle with a clutch. It's quite a nice arrangement because the motor's always running. This being a slightly newer machine or newer concept, there is no clutch. It's like a modern Harrison or Boxford or whatever. The motor stops and the spindle stops. So if you stop the spindle, the motor goes off. Now the problem with that is you're continually starting and stopping the motor, and it's a 10 horsepower motor, and on my house supply that causes the lights to dim. Not just in the workshop, but in the house as well. And I thought if it's doing the house, it's probably doing someone else's house who's on the same. So I thought I ought to do something about this, or else it's going to be a bit tricky. And that was very difficult because I don't know anything about machine wiring, electrical controls, anything like that. Are there any electrical experts here?
No, one of my colleagues, sadly not here now. What he's got is he has a motor running on the background.
Oh, right. just to dampen it.
Yeah,
Mhm.
so it stops it spiking,
Yeah,
basically.
I have heard
that's-
that one.
That's how he does his.
Tony
one-
Simon's recommended that actually.
Yeah,
Yeah.
one of my, he used to run a 4x4 business,
Mhm.
and it was a farm buildings, and he used to have this one big motor stuck up in the roof, just spinning over all the time, and he used to run all his ramps and everything
Mhm.
off 240 volts.
I guess it has to be a fairly substantial motor, does it?
Well, the one that your man used to use was quite a big thing.
Yeah.
It was running all the time.
Just to
Only
stop the
slowly,
spike.
just to stop everything spiking.
So the theory there is you've got this motor, when there's nothing running, you start the motor, it's a big draw on the phase converter, so you get the spike. Whereas if you can keep a motor running, the additional motor then starting up doesn't shock the converter so much. Well, yeah, it was a real challenge because, of course, there's other conflicting information about what you can and can't do. So I've had to pick through it all. What I ended up doing was, although the workshop is running on 3-phase already, so there's no need technically for an inverter, there's the motor. What I did was I bought a 3-phase to 3-phase inverter purely to give me a ramp-up time. Because a phase inverter used in your workshop, you're normally using it to get the 3-phase from 240. But as a byproduct, obviously, you have to program how long it takes to start up. So it might be 2 seconds, you know, for the motor to get to full speed. Now, what I've got here is just an inverter. 3-phase comes into it, 3-phase comes out of it, but the start time is set at 3 seconds. So when you start the machine, it ramps the chuck up, or it ramps the motor up, sorry, over 3 seconds, and the lights don't even flicker.
Soft
So it's a soft start. It's just a method of soft starting it.
Yes, I understand.
But the problem comes because this, as I keep saying, is a more advanced lathe design. It actually has a 2-speed motor. So you've got forward and reverse in 2 speeds. So you can set it here, there's your forward and your reverse. You can go for high-low on either. And then when you throw the apron lever, whatever it's set to on those dials is how it starts up. So let's say for screw cutting, you could have it set in reverse on high and slow on forward. So if you want to use the method where you leave the stuff engaged, you get to the end of your thread, retract the top slide or cross slide, throw it into reverse, and it goes backwards much more quickly than the old, because traditionally if you do that, you do your screw cutting, you wind it off, and then you've got to wait, you know, all that time while it reverses back, whereas you can have this set, you know, so it whizzes back. But the general consensus seems to be that you can't run a 2-speed motor off one inverter, because the inverter is just starting the motor. So if you wire 2 in, will it try and start them together? Or, I mean, I don't know anything about them, but basically I was told if it's a 2-speed motor, you're going to struggle running it off a phase inverter. So what we did, a chap called Paul Compton, who I know helped me with this, he basically just altered the lathe wiring so that this runs directly to the high-speed setting on the motor. So the motor is always running in high speed, and if you want to slow it down, you just turn the inverter down, because the inverter is variable speed. So the slower motor speed is entirely taken out of the loop. It's just wired directly to the high speed. So that has enabled it to run. It's got a soft start, so it doesn't dim the lights, and I think it'll give me enough speeds, you know, for general machining.
Well done.
So that's the lathe. Now I said we'd finish on this question: why are you building that? I'm building a steam locomotive, as mentioned, and sometimes on YouTube, often in real life, you know, people say, "Why are you building that?" Or and the question can be asked in 2 ways. It can be asked, you know, why are you building that instead of doing something more interesting? Or, you know, why are you building that instead of this? Or, you know, why are you building that as a generally interested question? So I did a bit of a video presentation on this to try and answer the questions, and these were the main things I came up with, assuming the person is asking why are you building that because they are considering doing model engineering themselves. And so I thought the key one was motivation. So for instance, in the case of a locomotive, why are you building a locomotive? For me, it's purely a mechanical engineering thing, so I think it's a great piece of mechanical engineering, a lot of moving parts, a lot of complicated parts. You've got the additional task of a boiler. So from a pure mechanical engineering point of view, there's a lot to it. I know other people build for nostalgia, or they're trying to make a perfect replica of something, or perhaps they're trying to make a one-off. They've found something they like and they're trying to recreate it in a model size. And then the decisions on what to build are more involved. Are you a beginner? Practical considerations like how you're going to move it when you've finished it. All that kind of thing. Time scales, a lot of people probably don't realise the time scales involved if they're going to take on a locomotive. And the other question then coming back is, from someone saying, well, what should I build? Would you recommend, what you're building? Or so this sort of question went on, and so I thought we'd finish up here with a bit of a group discussion. So I've put 3 questions down here. So of those of you involved in a project, why have you chosen to build what you're building? How did you approach it? So did you just pick it because you like the look of it? Did you decide I want to build this kind of thing and go and find the most suitable example? And motivation, so you're building it because you wanted to recreate it in miniature? Is it the engineering challenge? So we'll close with a discussion here on those points. Whichever willing volunteer wants to go first.
Well, I'll start. Many years ago, I got into model engineering. I'd done the Airfix kits, done the racing cars and everything else, and I went to the Wembley Model Engineer Show and saw all these lovely locomotives. I did metalwork at school in those days. I thought, well, I can scribe a line and use a file. I could do that. I knew how to use a lathe. So I went back and started on a Rob Roy because it was a beginner's locomotive, really. Allegedly. Yeah, if you read between the lines in the book. So I was a bit green, and then it still hasn't been finished, by the way. The boiler cost me 80 quid, so that tells you how long ago it was. Yeah, it was then. So I then went to Guildford because I was on my engineering course at Borden and guy asked me what I was building. I said, I'm building a Rob Roy. He said, oh, really? He said, do you want a passenger hall with that? I said, well, probably. He said, well, throw it away and build a simplex. It's really helpful. So you learn from joining a club, basically. But I'm a classic model engineer in the, got too many projects on now. That's how I got into it, because Rob Roy was a beginner's locomotive.
So you picked a locomotive because you like the look of them on the display you'd seen?
It was supposed to be a beginner's locomotive. I was a beginner, that's what I went for.
Yeah, so you found the beginner's project and attempted it?
Yeah.
And through a model engineering club built the knowledge?
Well, I didn't join a club until I came back to the UK. I was in services for years. But you get to go to shows and talk to people, and you see the finished thing. I've always been interested in mechanical things. My mother was an aircraft engineer during World War II. Mm-hmm. So I probably got the engineering from her. So I've always been interested in steam, even from a young boy.
Yeah,
so
okay.
That's how I...
That's your story?
Mm-hmm. Yeah.
Well, so my motivation, why have you chosen? Because it drives me absolutely insane once I've seen what I want. I've built 16 locomotives, and each one has burned me up all the way through, and I can't wait to get to the end.
And what's the reason for that? Is it the...
I'm potty, really. I suppose I went as a child. It's interesting to hear Ian say, I went as a child with my dad to Manchester Free Trade Hall and saw a locomotive by a guy called Louis Raper. I don't know whether any of you have seen it. 10¼ inch Aspinall 060. And I just stood there and gawped at it and wanted to do something. And it's interesting because when I went to where the Corpay was, I just stood and saw it, and you took a photograph of me transfixed looking at this. This is, I'm in my 80s. No, I'm not. I'm in my 70s. And I'm looking at this locomotive and I'm completely transfixed by it. And the nice thing is that that has stood the years, over 18 locomotives. So I'm still transfixed by the look of the thing, and I desperately want to finish it.
Want to make it, and you're a stickler for only working on one project until it's finished.
Well, I am, yes, but it's like, what's the point of a dog? I mean, you really, you know, you've got to be driven to see it through. And those of us who finish locomotives will share that. You've got to be driven, and you've got to be antisocial and peculiar. And I am all of those things.
Yeah, but a lot of people don't necessarily build. I mean, my son calls me a paper engineer because I enjoy the research and doing a project on that side. So, I mean, people use me or have used me as a knowledge source. Yeah. Because I do so much research. I've taken so many pictures. I mean, I sent somebody for building I met them at the museum, and they were building a Jubilee to Alcock's drawings. So he was a member of one of the Formula One teams, and he was in the museum. I sent him 350 photographs.
I think the entire build documentary for my locomotive came from Kieran, could have well have come via you.
More than likely.
Yeah. Yeah, useful source indeed.
Yeah, I mean, it's there we go.
Let's hear from somebody else. Trevor, come on.
Yeah, well, I can relate to both them stories, and just like you here, I started off with Rob Roy because it was a beginner's model.
Yeah.
So that was it, wasn't it? You know, the choice were already made for you in a sense, and so I started that, and I soon learned that it weren't a beginner's model, of course. And that, like Ian said, it wasn't going to be much good for pulling passengers. I mean, I have run it quite a bit here, but it's not what you'd call a passenger haul in local buses, by any stretch of the imagination. And back in about 2000, I decided I was going to build a springbok, and I got the drawings, and that were about as far as I did get. Because I soon learned that the castings, I think the set of wheel castings were about £200. Yeah. Set of cylinder castings were about £200. I thought, you know, this is a mortgage job, is this? And so then I moved to a J39 because this chap, at Stratford, because this chap in Lancashire did the castings at probably about a quarter of cast price of Reeves. And so I bought the castings for that, and I did the frames and I put the arms in, and no sooner had I done that than we'd gone to Grimsby and Cleethorpes Gala weekend. Yeah. And it was there where I saw a Hunslet. It were Keith Parkinson from Bradford Club. Yeah. And he got this thing there. It were a 4-inch, same as the one I built, and he had 4 coaches on, and he just ran it all day long, and that's what it did. It just ran and ran and ran, and totally effortless, you know. A shoveler call every now and again, just injectors. There were no pump or anything, just 2 injectors, and just top it up water now and again, and that were it, and that did exactly the same. Yeah, and so you've just gone on to build these things based on seeing one and wanting to have your own one of them. Yeah. 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 What about the builders of the internal combustion engines and other things?
Well, I don't think I'm a model engineer. I'm just interested in engineering.
Yes.
And what I do now is I design something that I want to build, and that's a big part of it.
Right.
And thinking through the problems of how you're going to make it and how it all goes together, how you can assemble it.
I think that's probably a common theme. I remember, is everyone familiar with Mike Sayers, who builds the third scale Bentley engine? I once asked him, what was his motivations and what bit did he enjoy and what, because he just keeps, working on these engines, and he said he likes sitting at his drawing board, working out the dimensions. He likes then the 3D chess element of how's he going to produce all these features. And then, in his words, the rest is sheer boredom.
I can't agree with that. The actual making of it is to me.
I think his point.
That's
his point was that he'd done that much machining that cutting aluminium, but every time he's thinking it through, it's a new scenario. Kevin.
Myself at the moment, I've got myself a new toy, a 3D printer, and 9 months before I made it. But what motivated me a little bit is that I'm ex-war engineers. War engineers built the railways in the First World War on the front lines. And I've got 2 very good books which detailing the type of wagons that they were using. So I'm teaching myself how to do it all. But I've learnt that what I like to do is build some of these wagons, that from the First World War, which they were using. And there's ones there that are really weird and wonderful ones for carrying large artillery pieces, which they have like a bulge at each end and the suspended at the bottom. But with the 3D prints which I'm learning to use, I'm making a lot of the frames and stuff by 3D, but I'm not doing it all because I'm making it as with metal.
Yeah.
I'm composite building it. I want it to look a bit more than just a plastic model.
Yeah.
I'm using composite building, but I want to end up with a train. It's only 16 mil in a train of Royal Engineer carriages.
In terms of your motivations for that, you're producing a replica as close as you can of an existing thing.
Yeah.
Yeah.
And it's good. I'm learning again.
Yeah.
When I started, I was always interested, particularly in vintage stuff. Steam, yes, but I knew absolutely bugger all about it. What is it? And Jeff Vickers used to have a second-hand shop at Gilligate. And I used to call in there most Thursdays. I used to do a service run. And I bought a little 5-inch gauge, 040 Peggy. Cheap enough. I've never used a lathe in my life. So anyway, I got this local and I took it home and I took it to me. And oh boy, I thought I might have made some mistakes, but this was ridiculous. But by getting that logo that was in one piece, I learned how it went.
Yeah.
The valve time, I didn't have no idea what the valve system was. I mean, you couldn't even push the bloody thing because the wheels wouldn't turn.
Yeah.
And it turned out that one axle box was way out of true.
All right.
But by taking it to bits, I learned what was wrong and how to put it right.
So that's a purely mechanical.
I've never used a lathe in my life, so I've had to learn myself because there's nobody near us who can do it either. I'm still not much bloody good lad, but I can make do.
Thank you. Dave?
I think of myself probably as the oddball here because I got obsessed by wagons.
Yeah.
Sounds crazy, doesn't it? But I'm afraid it all started with the idea that when you had a double gauge railway, what did everybody do? Well, they had thousands of locos and very few wagons, although not literally thousands, but you know what I mean. There was a tendency for you to buy one of each of these engines and then just have a handful of trucks. Well, because I was at my background was carriage works, I started out with carriage works at York. And I don't know, you started taking an interest, a real interest in the way different bits of different vehicles are constructed and the vast difference that there was in all the stuff,
in real life.
By the time you'd taken a Commonwealth bogie to bits, you realised how you had to get your fingers out of the way because they were a dreadful thing and you could chop a finger off as easy as winking, taking a bolster out of one of these. They were an absolute nightmare to work on.
But the interest sort of grew and crept in, and I set off like the rest of most people, I suppose, double gauge railway at home, and then I went to sort of G gauge, gradually progressed bigger, and then suddenly I decided I was going to start down the road at 5-inch gauge, right? And I built a CCT of all things, because there was one at Elsica that I could measure. I could actually get near it. This was after I'd sort of, you know, I mean, I got into stuff like this at the railway, but I could actually get near this one easily, you know. And I built a CCT, and I worked on the idea that I'd be able to ride on it and ideas like that. And I thought, well, maybe not. And after that, I got this idea in my head that it was in search of reality. That's the thing that's stuck in my head all the time, is in search of reality, right? Trying to make something in miniature that was exactly like the real thing. And so I built Elsica, which was a coal wagon, just a 12-ton coal wagon, because my wife comes from Elsica, and because I got photographs of all this there, and that was the first sort of real vehicle that I went out of my way to build. And probably I built 16-ton minerals, and what else have I built? Oh, I built the
snowplow.
Yeah, well, that's the last thing I built, Richard, was that I fell in love with, a guy came here and gave us a talk on Rosedale, right? And he had a picture of the snowplows that were at Rosedale. And they were unique, they were different. Because they only had 4 wheels for a start, which meant you didn't have to buy 6 wheels up. You were sort of and you didn't have so many axle boxes and this, that and the other of it. So I thought, this is a great idea. And I made up my mind that night that I would build one, right? Little did I realise what fun I would have trying to find out any information about these. Gradually I clawed bits from here and there. The National Railway Museum, dare I say, wasn't any help. But I went to North Road at Darlington and started there, and I began to get more pictures there that I could look at the detail work that had been, because of course, you know, they just didn't exist anymore. And I went to Shildon and got them to let me crawl all over the big plough that's there to get ideas of what was inside and the layout of the boarding and things like this. And in the end, you have to turn around and say, I'm going to start. Otherwise you never will, you know. Now, obviously along with this, it's not just metal work, it's woodwork, lots of woodwork. So I enjoyed the variety. I do all sorts of crazy things, like I realised that the boarding on most wagons, especially vehicles that had a body on them, you've got the planks running one way on the inside and the opposite way on the outside, right? So I started devising this thing that I would lay this out on a flat surface, glue individual boards together, and then glue individual boards together the other way, and then mark it all out and cut it out. You see what I mean? And you've got something that was phenomenally strong when you've done all this. Of course, being as I ended up at Bootham School for the latter part of my working life, I had access to plenty of oak, plenty of mahogany, teak, and stuff like this. So I was able to start saying, well, if I'm going to make an oak frame, it's going to be an oak frame. Can you see what I mean? And I would say, and if there were pine planks on the body, then it would be pine. You know, and it, like Richard says, it gets you. It's like a drug. You get sort of driven with this, and drives you crazy trying to find out information that you can't. Then of course you have a breakthrough. The brake gear was the breakthrough. I could not figure out on this photograph what this brake gear was like on this snowplow. There were very few pictures of it with the skirt off. And I'd managed to track some, you know, pictures down, but they were lousy photos really. And by the time you got a photo copy, it was even worse. But I was at Shildon one day wandering around, and all of a sudden there's a coach there, and I thought, that's it. And of course this was
Before phones.
it was a coach with the brake gear on, and it was Stockton and Darlington. And even though this coach was supposed to be North Eastern, they built this at Darlington, and it had still got Stockton and Darlington brake gear on. Real crazy bits where the arms hang over the axle boxes and the brake gear slides, as opposed, you know. And I thought, that's it. I've got it. I've got the answer. So you photograph this and you measure it, and all sorts like this, don't you? You know. And this is what it was like the whole time you were building it. It was bits of breakthrough that you kept finding along the way. And well, in the end, I built it, and I've seen it, and it did well for me at Doncaster. I was, you know, and it's satisfaction. It's just really satisfaction. The fact that you've achieved it, you know. And again, you could turn around and say, that was totally from scratch, because of the fact that you were, all the time, you were gleaning bits of information and trying to check it, and then finding you've got it wrong, because after you've started something, you find that you've done it wrong because the information came along later, and constantly trying to sort of change this until, you know, until you're satisfied with what you've built.
Yeah, thank you very much. Right, well, we'll wrap up in a minute. Just before we do, these have been great discussions. Does anyone have any objections if I use any snippets of them in future videos? Of course not. No? Okay, and with that then, I'll say thank you for listening, and if there's any general questions, I'll be happy to take them. Or are we all discussed out?
That was very good. Basically, you said, I think.
Yes,
Yes.
Well, Crispin, it's always lovely to have you here. We do regard you as our protege who has made good, and we're very proud of what you've achieved, both with the YouTube stuff and your competence as an engineer at Rolls-Royce. But it's been fabulous tonight, because you've managed to involve people, and that's something which most speakers don't normally do.
Well, it was nice everyone was happy to be involved.
Of course,
sure
we were. So thank you for coming all this way. Thank you for doing a brilliant presentation, and we look forward to perhaps inviting you next year if you'll come.
Yeah, okay.
Your check's in the post.
Okay, well, I'll see you all next time. Well, there we are. I have talked at York. Now back to the requirements of some machining related activities. Now that is quite enough talking for one day. Hopefully you're still with us, or at least still with me, and I'll say I hope you found that interesting. Thank you for watching, and see you on the next video.